Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I'm John Calloway.
And I'm John Ash.
Thank you very much. Thrilled to be here.
So, Mads, before we kind of get into the meat of things, would you just give our listeners maybe an introduction to yourself, kind of tell them how you got started in the industry?
Sure. I'm a Dane. I grew up in Denmark, and as I was thinking about what I should do, I was one of those slightly nerdy kids who was fiddling around with computers and so on. But it was only very late that, almost on the day of the application deadline of universities, that I decided that computer science was what I was going to go into. And then for a long time, I was certain that I was going to be on an academic track with that, doing research and teaching. And I actually ended up doing that for several years before I'd had enough exciting collaboration with industry and kind of contributed enough there that I realized that was much more fun and paid a lot better. And that was I might as well get paid for the fun I was having and hop on over to the other side. And I was lucky to run into Anders Heilsberg, the father of C#, just around the time when I was having these thoughts. And a year later, I moved to the state of Washington.
Okay. So what was that transition like from going from like in academia into the industry? What was that? I mean, you obviously like that, or?
It was extremely baffling to me. I think it was a combo of moving from a public university to a private company, also moving to a different country with a different culture, uprooting my whole family and all that. It was is discombobulating a word? I think it is.
It is.
And in many ways, in the beginning, not at all what I thought it was for, which was do language design all day, but get paid better. Because of course, just like being a professor has all its menial tasks and all the things that you have to do before you get to the fun bit, so does working in industry. Everybody else seemed to know that, but it kind of took me by surprise. There's a little bit of an adjustment there where, they actually expect things to come out the other end on a certain schedule. And, so but it was jarring in the beginning, but I very quickly learned to enjoy working as a big team towards the same goal and having real customers. That's fantastic. That was a complete revelation to me. The sense of actually having thousands of millions of people using the thing that you build. So it also quickly grew on me, and pretty much I've never looked back. I really enjoy being in the industry now.
So these days you're a program manager for the C# language. So what is that? What's your daily your average day or typical day? What kind of things does that sort of entail for you?
Well, it's changed a little over the years. The bio there is a little old. I should probably have given you a new one, but I'm still a program manager. I report to a program manager and everything. So I'm a program manager by title. But in the sort of program manager discipline, that implies a lot of things that I don't do a lot of anymore, like a lot of coordination and stuff that I am really mostly today essentially after Anders Heilsberg left C#, to have another kid with another family. And I took over as the lead designer for C#, and it's been increasingly my work is focused very much on the actual language design. Like now I actually do language design all day almost.
Okay.
Imagine in the beginning. So we have a language design process that involves well, first of all, it involves a lot of community interaction in GitHub, but it also involves a substantial amount of time spent together on the language design team, which is a group of people from across physical teams that meets 4 hours a week to move forward the design of C#. And I run those meetings and kind of take a lead on that.
Wow.
And we're about 4 or 5 months out after the release of C# 8. Is that correct? Is somewhere around that?
Yeah,
and I know
right.
that there's been a lot of discussion, a lot of excitement around the new features. Do you want to kind of walk us through a few of the key features that maybe people are still excited about or still finding out about and putting to use?
Sure. I think that the feature that everyone probably gets a chance to be touched by, no matter what you do, is what we call nullable reference types. It's sort of cheekily named because people have been asking for at least a decade for non-nullable reference types in C#. And so instead of that, we gave them nullable reference types. The idea being that in C# 8, you can start distinguishing whether variables of reference type or parameters or return values and so on, whether you can sort of express whether they should be null or not, whether they should be allowed to be null. It's one of the big quote unquote type holes in C# and in all object-oriented programming languages that anything can be null at any time. So when you say that something is a vehicle or a student or a whatever it is that your domain is modeling, it really means it can be one of those or absolutely nothing. And you always have to worry about the absolutely nothing part. And if you forget, your program blows up in unpredictable ways. And so and there are ways to incorporate that into the type system. And we've chosen one of those ways where you explicitly express the nullability of a given thing, but we've also chosen an enforcement model that's pretty light touch. You have to turn it on to even get it, and it only gives you warnings. And the reason for that is partly that otherwise you get a system that's too restrictive to really use and practice. And also we're adding this in the 8th major version of C#. And so there's a whole lot of code out there already. And we don't want to put too big of a burden on people for adopting this. So it's kind of coming in with a light touch where it gives you a great amount of feedback on possible null errors as you're writing new code without bombing you back to the Stone Age in terms of your existing code or in terms of hard to express scenarios. So that's sort of been the balance of it. And everyone can turn it on and start getting that kind of feedback. That's the major, the feature that probably has the biggest impact, I would say.
Sure.
Yeah. I hope it will be on by default one day. In terms of on by default in the Visual Studio template or wherever you code that you start with for a new project. I would definitely recommend everyone to have it on by default, or to have it on in new projects. The reason it's not on by default is partly that we definitely don't want to do it for existing projects, because now all of a sudden if we start turning it on for existing projects, you get like null warnings that it's probably good to deal with, but it might not be what you want to do right now. But also, we want to give all the libraries that people depend on, including our own core libraries, our own BCL, give some time to adopt nullability into the signatures that we expose. And during that grace period, so to speak, your warnings are going to change all the time. Like the library you depend on, every time it upgrades, it might lead to more warnings, even though you didn't change anything in your code. So we want to have a little period of time elapse where people have had a chance to get their nullable annotations in, so to speak, and before we turn it on by default that your client code should expose those warnings. Otherwise, all the churn is going to show, downstream, and that's going to be sort of a turbulent experience, if you will. But I hope that maybe already at the time that we shipped .NET 5 in I think in November of this year. That's sort of my optimistic view is we should turn it on by default then. But let's see what the landscape looks like then. But that's sort of called the nullable adoption period, if you will, is hopefully runs to around then. Right. Mhm. We spent inordinate amounts of time talking about that problem. It is very that is very pertinent. It is a problem, and with this particular language feature, we had the benefit of not being we're not pushing the state of the art here. There are other languages that have done this before us in various variations, but the one in Java, for instance, is close enough that we could sort of look at what worked and didn't work for them. And it turns out that what we do is that if we know statically that you have two default implementations colliding, then we say, nah, you have to provide your own because those two are in conflict. We don't know which one to pick. So it's only in the situations where you sort of do compilation out of order that you can get yourself into. You're there at runtime. When you compiled, you thought there was an obvious choice. And so the compiler just said fine, but then at runtime, one of the other things that interfaces you implement also has an implementation for this same thing. And then you get a runtime exception. And this turns out to be exceedingly rare. So for this kind of scenario, it's not really a big deal. I think that if we had full-blown multiple inheritance, then we would start to have a problem with that. But it turns out to not really matter that much. Yeah, exactly. And you only ever even get this problem if you start overriding default implementations in interfaces that derive from other interfaces, which I think in itself is relatively rare. I think most times you give a default implementation when you introduce the member in an interface, and that's that. And if that's all you ever do, you will never have this problem. It's only for overrides that compete in deriving interfaces, and that's it's really a corner scenario, I hope. So far that seems to be true. Yeah, you're right. I was exuding a little too much confidence there. They're going to take it on
it. So I guess one question I have is what was the feature that you added or that you guys added here in C# 8 that was sort of your favorite? So you talked about nullable reference being the one that sort of impacted people the most, but did you have like a particular thing that was really sort of like your baby, the thing that you really wanted to and were excited to see happening?
That's really hard for me to pick. I mean, I had a lot of fun, but also I had a lot of night sweat over nullable reference types. So that was really the one that was it was the problem child, the squeaky wheel that gets all the oil. But I really like how it turned out. It's also a very complex feature. I think it's the one of the features that has the most long-term impact. So if I had to pick one feature that was the only one of them all that I got to put in C# 8, that would be the one. But that said, there are some that I think are just super nifty that I'm really happy that we did. Also, like the recursive patterns and the switch expressions and so on. They make for such beautiful code when you have just the right scenario for it. Like you can really write your conditional logic in a way that feels declarative and it sort of visually tells you exactly what it does and so on. And that stuff I really like that. And then we also did what we call async streams, which finally takes the INumerables sequences and combines them with async, which is something we considered doing back when we first introduced async, and we realized various things just weren't mature enough or efficient enough at the time, and we didn't do it. But now we finally have we had all the puzzle pieces to do it right, and so now you can wait for each, and you can produce async enumerables out of iterators with you return and async methods, and it all just clicks together, and that makes for some beautiful asynchronous programming. Like essentially anything that consumes streams that come over the wire that take place over time, you can write that code much more elegantly now. And if you, for instance, look at the gRPC bindings in C# now, they're just beautiful because of that. Like you consume a stream and it's elegant, man. So so I like them all in their own way. You can hear how I can all sort of squint together. There's nothing in there I don't like.
Sure.
Yeah, it seems like there was a lot of chatter on Twitter, people talking about the pattern matching enhancements, the switch expressions, but they were also talking about like the using declarations and their use. And I've run across ReSharper telling me that I can convert some of my own code as I'm doing that, and I think it's going to take a little bit getting used to, or maybe it's a little enhancement in Visual Studio to change some indenting or some kind of visual representation. Because at some point I miss my curly braces telling me that this is where the using occurs, and this is the scope of that.
This is a good sort of general language design problem, right? You have the tension between making something as lightweight as possible in the syntax versus calling it out. When do you want to take up more screen real estate and more indentation real estate, which is really expensive, right? Which is really precious, to make something evident. And C# traditionally has erred on the side of let's throw in curly braces everywhere, and you get some indentation and some very low usage of screen real estate. And we've definitely moved the language more in a terser direction, where we say, okay, sometimes it's more important that you can see non-trivial parts of your code at the time than the having the indentation just right. And so the using declarations, which is using var or using string or something like that, and they sort of implicitly get cleaned up at the end of the scope that thing is in. It's good for when it's obvious what it does, and if it's not obvious enough to you, then put in the curly braces, and no one should, like, I know there's that young new hip developer who's gonna try to smack you for it, saying, "Oh, you could actually make it shorter here," and you just say, "Yeah, but I don't want to because it's important that I." Mm-hmm. Yeah. Well, I wouldn't rule it out, but but it was the thing that finally made us converge on a good range design was that we scoped out anything that didn't have to do with indexing. So we said, okay, range is not some like generic type where you can have ranges of floats and ranges of complexes and whatnot. And it's just ranges over ints. And it's for use with indexing, because that made a lot of those questions around ranges as a general concept just fell away, and you don't have to worry about those anymore. So that was the first sort of that was the thing that really let us kind of focus in on a design that was then optimized for the range of indexes kind of scenarios. And that also made it easier to make the decisions around exclusive versus inclusive and so on. The thing is, in Ruby, if you say do or in or whatever, 1 to 100, you expect both 1 and 100 to be in there. The ranges we have actually aren't like that. They're if you say 0 to 100, then you get 0 but not 100 in the range. And that all is motivated by the indexing scenario. It makes total sense when you're indexing. That's how arrays work. If you allocate an array of 100, you have 0 through 99 in there, and so on. So the whole design was just much easier to lock down around that. But it means that some of the other scenarios aren't so intuitive or don't work at all. And we just said, okay, let's not do those right now. And maybe even if we do them, instead of the ... we will use a keyword, and we'll make them different. And 1 keyword to 100 or something like that.
All right. And there's been a lot of documentation, a lot of conversations, a lot of blog posts and podcasts about all the latest and greatest features for C# 8. What can we look forward to for C# 9? Have you guys started already defining what's going to be released? Is that something that we can look forward to with C# or with .NET 5 this fall, or what's next?
Yeah, we're working hard on C# 9 already. One of the things that we're focusing on is sort of what we call quote unquote records. It's a loose kind of bucket term for allowing you to declare data types maybe in a simpler way, maybe in a way that that is more accommodating to immutable data, representing immutable data and working with that. Where object-oriented programming is sort of very biased to objects that have a rich inner life, so to speak. Like they're encapsulated, and they come with a lot of functionality that's virtual and encapsulated, sort of hidden. Oftentimes nowadays, you just want to represent data. You kind of have to almost work against all the defaults of C# in order to do that. One of the things that is really nice since C# 3 is object initializers. A lot of people now write classes without even bothering with constructors, and because it's so they just have properties, and now when you create them, you quote unquote have to set the properties explicitly in an object initializer. But that's actually nicer, and it reads better, and it lets you it gives you better syntax for omitting things that are optional, and for nesting things and so on. So that's actually really nice syntax. But the semantics of it relies heavily on the objects being mutable. In order to pay for the convenience and beauty of the object initializers, you're now leaving your objects vulnerable to being mutated, and that's not necessarily what you want. Like, certainly not if you're exposing them in an API or something. You might not want to do that. And so one of many things that we're looking at with records is how can we allow object initializer syntax on immutable classes, or rather, how can we let you declare immutable classes that still allow object initializers? And how can we also use object initializer syntax for what people sometimes call non-destructive mutation? So when you work with immutable data models, you often you often create a new one that's like the old one, except with some deltas. So the next version of a thing, you represent the evolution of time, not by physically changing the objects that are already there, so the old version is destroyed forever, but you create a new one that's just like it, and maybe it shares some of its, maybe it's a tree and they share some of the subtrees or whatever. But non-destructive mutation is something that's typically not very well supported in languages, and we want to make it well supported. So essentially, you can say, John with last name equals, and then you can change it to Callaway or whatever, and evolve objects like that without breaking the old object, but creating a new one that's a copy with a few things changed. That kind of thing.
That seems like that would be really useful for sort of the document paradigm, where you have sort of changing documents or NoSQL data that's coming back, and you don't really know what kind of structure that's going to be necessarily having, and you might be changing that kind of on the fly as you go.
Yeah, I think you could.
Cool.
So that's what we're noodling with right now. There are a few other things that are on the docket as well. Another thing we have a prototype of right now internally is, well, nothing's truly internal anymore. You can go find it on GitHub, but is allowing statements at the top level of your program, instead of having to put them inside of a main method inside of a class. You could sort of write your main program just on top of your file, which is, I think, a meaningful simplification, especially if you're learning a new language or just want your program to look simpler. Instead of you having to go visually hunt for that main method using the same algorithm as the compiler uses, why not just have the code sit there on top of the file? Stuff like that.
So as someone who spends a lot of time writing line of business applications, I'm not often busy thinking about how the language needs to optimize and what features need to be in there, but you guys are doing that. So one thing that's curious to me is sort of if you could talk a little bit more about sort of your team's approach to sort of uncovering those new features and prioritizing them and saying, this is where we think our best efforts go.
Right. It's one thing that we've focused on a lot at Microsoft nowadays, and in developer division certainly, is trying to be more scientific about these things, or at least trying to be more data oriented, or evidence oriented. Mm-hmm. And that's, when it comes to language design, that's super challenging, and it's not. And to be honest, we're not very good at it. I mean, we haven't really cracked that in terms of, okay, how can I do a really evidence-based decision process, prioritization process here? We get a lot of signal, and a lot more signal now that we're open source, where not just through the GitHub site itself, where we get a lot of input, but also just because we can talk about our plans when they're half-baked instead of waiting until we figured it all out, and we can get feedback on that, and we can share prototypes and so on much more easily. So being in the open gives us much, much more signal. We don't really have sort of a super scientific or quantitative way of sifting through all that signal. It's really much more about just keeping an eye on a lot of things, and having I mentioned the language design team before, and that is I try to keep that as diverse as possible in terms of people's backgrounds and perspectives and value sets, so that we get we can kind of use that group to integrate a lot of the different perspectives that are out there in the world and try to weigh them against each other in a way that doesn't involve 1 million people, but only involves 10 or 12. So we have to use these more ad hoc or anecdotal approaches. Just try to do it as best we can with our experience and our intuition, And you know, oftentimes people will tell us when something doesn't sit right with them. It happens, and so we can kind of say, does this have laid? Are they right about this? Are we missing this scenario? Or are we stumping on that scenario? Are we not really hitting the target here? And oftentimes they're right. It is more of it's a little more of an art than much of what we do.
Cool. Yeah, that's really cool.
Of course, I didn't mention so much, but we look at other languages a lot.
Oh, sure.
And we talked about default interface member implementations before, and yeah, absolutely, we borrowed a lot of that, and sometimes other languages borrow from us, and we are happy to flatter them back.
Nice.
Yeah. Hmm. It's definitely not a feature that we expect or want to have broad usage of. So one of the things that we've done successfully, actually much more successfully than I thought we would, to be honest, is pushing the boundary of C# further down so that you can write safe, efficient systems level code in C# in many cases that is totally competitive with code that's written in C or C++, but keeps you in C#, right? And has some safeties that you wouldn't otherwise have, and also not the interrupt. Sometimes we still do need interrupt, and function pointers are part of that, of having good, efficient interrupt. And so I expect most people that use function pointers to well encapsulate that in a small corner of the implementation of some library and not make it broadly available. So, I mean, C#, the fact that we even have unsafe in the first place, which we've had all the way through since C#1, is a concession to interop and to the fact that there are other things underneath, and we better interoperate well with them. And it's okay to spend some feature surface area on that for the few people who can keep track of that and make it safe. So we still do that. We also sometimes pull things into the safe part of the language. The whole span of T push that we had a couple years ago was about making many of the scenarios that you previously needed unsafe for, make those safe and track more in the type system. So yeah, it's not we're not going to really be advertising that feature much, because I think if you don't know that you need it, you don't. But we have to do that kind of thing as well, and we try to do it as tastefully as possible, even when it's on that end, because there are real people that will be using that for real, and also a lot of generated code probably would make use of that, generated interrupt stubs and whatever people do. So.
It does kind of bring up an interesting question: is it possible to, and where maybe this line might be, to be adding features that just don't belong and are too, because of their ability to burn you, and if you don't know how you're using it, right, it could be well destructive, that you say, well, no, we're just going to keep that feature away. And how do you make those decisions?
Yeah, well, if we definitely think about the destructive potential of a feature, and I don't know if we have again, we probably don't have a super well-defined process for it, but certainly if we do a feature like function pointers, it's because we have so we essentially make a concession to doing features. We try to add features that benefit a lot of C# users.
Mm-hmm.
Occasionally, they do it indirectly, right?
Mm.
They will have safer, faster libraries because this feature exists, but they will never use it. And so sometimes there's that kind of thing. If it's that kind of feature, then okay, and it's kind of clearly it clearly kind of identifies itself as something that you probably shouldn't touch. And then it's okay. We even sometimes talk about those features shouldn't be too nice. Like they should be a little ugly. You should have to pinch your nose when you use them. Yeah, obviously we sort of have a sense of what is, for features that for broad usage, we really do want them to be hard to use wrong.
Yeah, sure.
Obviously, any dedicated disruptive soul like 80% of our users could, if you really want, you could really go and abuse most features. And we sometimes have this discussion where we're like, oh, this could be abused this way or that way, and we're like, yeah. But when you do that, you're abusing it. So, okay, that's fine, but if it's sort of like a pit of failure where, oops, I held it wrong, and now my program is on fire, then it's not so good. So, yeah, we try to strike that balance between not being overprotective, where you can't do anything fun, and also not like leaving these big landmines in your way. And there's a good broad design space between those two extremes.
All right. Where should we be looking and paying attention to finding out what's coming down, in future releases? Are there specific docs pages or blogs or specific repos that we should be paying attention to?
Yeah. First of all, for current releases and even upcoming releases, docs.microsoft.com now has, the C# docs on there are just excellent. And as soon as we start coming out with previews that have the new features in, that site also starts lighting up with preview docs that go with that. So I'm now it wasn't always like that, but nowadays I'm very proud to refer people to that stuff. If you know of Bill Wagner, who's written several books on C#, he's kind of the driving force behind the docs now, and they're excellent. They're great. If you want to keep an eye on what's further out, there's not sort of an easy one-stop shop where you can sort of just go and see the status of all ideas that we have and that we're working on. You have to follow the process a little more. There's the .NET/C#Lang repo on GitHub, which is where that's where our process is for language design. The quote-unquote code in there is docs. It's meeting notes. It's proposals, and then discussion happens through issues there and so on. So you can go there and piece together a picture of what's going on, but it's not like easily consumable. And then as things grow nearer, we'll also start having talks, even that go into some of the speculative stuff that you can go and find. And if you look up talks with me in them that are relatively recent, chances are I'll be talking about some of the craziest stuff we're imagining, as well as existing features. That's a way of kind of getting the first, like, oh, okay, I guess Mads is interested in that stuff. That might be happening. And then you can go and search for that on GitHub and find out more.
Okay. We didn't exactly talk about this when a lot of the stuff we're talking about was sort of features that maybe someone who's been using C# would use, but is there any resources that you might like point for someone who's like trying to get started into C#, either whether they're coming from someplace else or just from knowing no programming at all?
Yeah, first of all, there's several books that use C# as a first programming language to get you introduced, and I say that without being able to rattle off any titles or authors right now, but they do exist if you're book oriented. I know that we put out, Scott Hanselman is in some of them. Several people are involved in putting out short YouTube videos that are really introductory programming using C#. I have to admit I haven't watched that many of them because I know most of these things. But I hear they're very good, and they're good sort of bite-sized things that you can grab one and you come home from work and you can grab one and kind of spend some time playing with one little aspect, and so even if you're not a programmer yet, you can sort of get ramped.
Okay. One of the things, and this is sort of wrapping up in a different direction, we ask all the guests that come on if they would sort of give their advice or words of wisdom to people that are just getting started in the industry. Sort of like, what things would you specifically tell them?
Oh, that's a wonderful question, because it's hard. I think that, one thing to say is that your environment matters a lot. I think that we all love, most of us are in the industry because we love the technical stuff. We love like the intellectual challenge and so on. And most of us can get fulfillment or some sort of fulfillment on that. But the kind of place you work and the way you set yourself up when you're in a place, the expectations you set with other people and so on, that you really have to think about the long term. Is there are you in a warm, welcoming, supportive environment, or is it toxic? Are you establishing yourself as someone who will work 12 hours every day only to burn yourself out? That kind of stuff ends up, you want that kind of stuff not to matter. But for it not to matter, you really have to think about it up front. You want that not to be the thing you think about all the time, the thing that keeps you up at night. If a technical problem keeps you up at night, you're in a good place, right? That means that you are not feeling stressed out because your boss is being unreasonable, or because your colleagues are bullying you, or because you don't feel you fit in because you have a different color or gender or whatnot. That matters, and whoever you are out there, you deserve better. You deserve that stuff to be good, and you should make some sacrifices if necessary to get yourself in a good situation there, and the rest will come.
That's excellent. I think that's pretty unique too. We haven't had that. I try to keep mental logs, and we've even reviewed what people have said, and that is one that's been really important for me in all of the jobs that I've gone after. I really try to take an assessment of the kind of culture that I'm going into. But I strongly agree with that advice, and it's also very unique. So we haven't had anyone share that. So thank you so much. How about if our listeners wanted to sort of follow you or reach out to you, is there like social media platform, or what methods should they do that?
Twitter's good. I'm Mads Torgersen. I'm not a super frequent user, but I'm also not completely absent. So that's not the worst place to find me. And if you do things on GitHub, on a repo there, that's also a place where I have to spend some time as part of my job. So I'll see it there as well. But Twitter's probably for sort of drive-by interaction. That's probably the best place.
All right. Thanks, Mads. Really appreciate you taking the time to speak with us today.
Thanks for having me. That's been fun.
That was Mads Torgersen. Mads is the program manager for the C# language. He maintains the language specification and runs the language design process for C#. Many years ago, Mads was a professor and also contributed to a language starting with J. Find show notes, blog posts, and more at sixfiguredev.com.
And be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
And I'm John Ash.